Let's solve dy dt minus ty equals 5t. This one is already in the form y prime plus p of t y equals g of t. So we can see that it's linear. So step one is already done. Next we need to compute mu, which is e to an antiderivative of p of t dt. And we can see that in our equation, p of t is minus t, because that's what's multiplying the y. An antiderivative for p of t dt for us then is minus the integral of t dt. That's going to be minus 1/2 t squared. And remember, we don't need the c yet, because we're just needing to find one antiderivative for p, not all of them. Mu then will be e to the minus 1/2 t squared. And there's no simplifying we can do with that. So we'll go on and multiply both sides by this integrating factor mu, which for us is e to the minus 1/2 t squared. So let's do that. I'll get e to the minus 1/2 t squared y prime minus e to the minus 1/2 t squared t y equals e to the minus 1/2 t squared times 5t. The point of doing that is that this left-hand side should be in the form mu y prime plus mu prime y. And if so, then we can write that left-hand side as the derivative of mu times y. So before going on, I want to check that the left-hand side is actually equal to d dt of mu y. So d dt of mu, and our mu is e to the minus 1/2 t squared times y. Using the product rule, I'll have e to the minus 1/2 t squared times the derivative of minus 1/2 t squared, which is minus 1/2 times 2t. And then I've got the y, and then I'll add on what I get, leaving the first factor alone and differentiating the second factor y as a y prime. Let's clean that up. The 2's cancel in the first term. I'm going to bring the minus out front. So we'll have minus e to the minus 1/2 t squared times t times y plus e to the minus 1/2 t squared times y prime. And that's exactly our left-hand side, except with the two terms written in the opposite order. So we're good on that. We haven't made any mistakes so far. Now we should be able to integrate. As I do that, I'm going to write the left-hand side in the form d dt of e to the minus 1/2 t squared y. And then I'm going to integrate that. The right-hand side was 5t e to the minus 1/2 t squared, and I'm going to be integrating that. The left-hand side has that nice property where the integration and the differentiation cancel each other out, leaving us e to the minus 1/2 t squared y. On the right-hand side, I'll do a u substitution. We'll let u be the function that's in the exponent, minus 1/2 t squared. Then du would be minus 1/2 times 2t dt. In other words, du is minus t dt. So I'm going to be putting a minus du in for the t dt. I'll bring the 5 out front. I'll bring the minus sign out front that is part of the t dt. So minus t dt turns into du, and then I have e to the u. So at this point we have e to the minus 1/2 t squared y equals minus 5 e to the u plus c. In other words, e to the minus 1/2 t squared y equals minus 5 e to the, and our u was minus 1/2 t squared. We have our plus c. So the last thing we need to do is to solve for y, which I'll do by dividing both sides by e to the minus 1/2 t squared, or you can think of it as just multiplying each side by e to the positive 1/2 t squared. Either way, we'll get y equals negative 5 plus c e to the 1/2 t squared. Again, the way I'm getting that is I multiplied both sides by e to the positive 1/2 t squared. And if you distribute that in and simplify, I think you'll be okay getting that final answer.